Okay, hi, Assalamualaikum. Okay, today kita akan buat Johnson rule for 3 machine. Okay, in the YouTube previously we looked into 2 machine. Now we going to do for 3 machine. Okay, they have extra step for 3 machine. Okay, so let's look at this example. Okay, dia ada machine 1, machine 2, machine 3, and they have 5 job. Okay, job 1, job 2, job 3, job 4, job 5. Okay. In Johnson rule, they will always ask you on the total processing time. Okay, overall processing time for 5 job in 3 machine. Okay, they want the total. Okay, and then they want also the total idle time of workstation. So maksud dia, idle time for each, we have to find for each machine, and then we total up for 3 machine. Okay, when is the time that the machine don't do anything, just tunggu. Okay, waiting. And the last one, they usually nak tahu the job waiting time. What are the job waiting time between the job? Job 1, 2, 3, 4, 5. Which job yang have waiting time yang tinggi? Which job yang have to queue up in front of the machine? So we want to get this information from the Johnson rule. Okay, first step is when you have 3 machine, you need to do combination. Okay, first okay, remember untuk Johnson rule, we need 2 column to arrange the sequence. So for this one, we need to combine machine 1 and 2, and then 2 and 3. So for column 1, machine 1 and 2, kita add, and then for column 2 here, we add machine 2 and 3. So let's do the first column, in which 4 plus 4 is 8, 9 plus 5 is 14, 8 plus 3 is 11, 6 plus 2, 8, and 3 plus 6, 9. Okay, we're done with the first column. Then we're going to do for second column, in which 4 plus 6 is 10, 5 plus 9 is 14, 3 plus 11 is 14, 2 plus 8 is 10, and then 6 plus 7 is 13. So we're done with the second column. Now we will start do the sequence. Okay, so since ada 5 jobs, so you need 5 slot here. Okay, let's start to do the sequencing. Okay, from these 2 column, we will find the smallest time. So for these 2, okay, I nampak 8, okay, and also 8 here. So we do for the first one. So number 8 is the smallest between these 2 column, and which column is the first column? So it will go through this side, okay, from this side, and then what we're going to put here, the job number. So job number 1 will be here. Okay, next, okay, we find the lowest is 8. Okay, job 4. Since it's the first column, so it will go through here. So where 4 will be? So it's going to be here. Okay, next is 10. Okay, 10 we done because we only use once. Okay, job 4 is done. And then, okay, 9. Okay, we nampak 9. So 9 in the first column, so it will go through here. So job 5 will be here. Okay. And then, okay, 10 is done already. This one also done. Okay, we have 11. 11 in job 3. So since it's in the column 1, so again, we're going through this way. Okay. So this is going to be number 3. And automatically, we know, okay, number 4. Okay, number 2. Okay, number 2 going to be here. Right? So these are the sequence that we're looking for. 1, 4, 5, 3, 2. Okay, once we get the sequence, okay, you're going to do the in and out table for each machine. So for the first machine, in and out. Okay, and the second machine, in and out, and third machine, in and out. So where this sequence going to be? It's going to be here. 1, 4, 5, 3, 2. Okay, this is very important. If you get this wrong, so automatically your calculation will get all wrong. So 1, 4, 5, 3, 2. And then how to start? We start with 0. Okay. What to add here? So this is 0 plus job 1, machine 1, 4. So 0 plus 4, 4. And then you bring 4 down here. And then job for machine 1, 6. 4 plus 6, 10. Okay, bring 10 here. And then job 5, machine 1 is 3. 10 plus 3 is 13. Bring 13 here. And then job 3, machine 1 is 8. 13 plus 8 is 21. Bring 21 here. And then job 2, machine 1 is 9. 21 plus 9 is 30. So we're done with machine 1. Okay, now we're going to do machine 2. Machine 2, what number to start here? We bring this number here. So 4 going to be here. And then what to add? We look at job 1. Now go for machine 2. So job 1, machine 2 is 4. 4 plus 4 is 8. Okay, now can we bring 8 here? No. For machine 2 and 3, we need to compare 8 and 10. So we're going to choose the biggest number. So going to be 10. 10 plus, okay, job 4, machine 2 is 2. 10 plus 2 is 12. So we need to compare 12 and 13. Going to be 13 here. 13 plus job 5, machine 2 is 6. 13 plus 6 is 19. Compare 19 and 21. We choose 21. And then job 3, machine 2 is 3. So 21 plus 3 is 24. And then 24 and 30. We choose 30. And then job 2, machine 2 is 5. 30 plus 5 is 35. So we're done with machine 2. Now we're going to do for the third machine. So what is the number to start? We're going to choose this one. So 8 going to be here. 8 plus job 1, machine 3 is 6. 8 plus 6 is 14. Okay, again, for this machine 3, we need to compare 14 and 12. So choose the biggest one, going to be 14. So 14 plus job 4. Job 4, machine 2 is 8. 14 plus 8 is 22. Again, compare 22 and 19. Choose 22. Job 5, machine 3 is 7. 22 plus 7 is 29. And then 29 and 24. Choose 29. 29. Job 3. Machine 2 is 11. 29 plus 11 is 40. And then 40 and 35. Choose 40. And then the last one is job 2, machine 3 is 9. So 40 plus 9 is 49. So we find this 49 at the end, and this is an important number. Why? This will give us the information on total processing time for 5 jobs in 3 machines. Okay, sometimes they ask you about the total throughput time, total machining time. Okay, these are the numbers that we're looking for. So 49 minutes, because the question is in minutes. So you need to put the unit here. Hours, days, minute, second. So it depends. Okay. So for this question, it shows the minutes. Okay. Now we want to know the idle time of these 3 machines. Okay. When the machine not doing anything, they are waiting for the jobs to come in. So for the first machine, it's only okay, for the first machine is only at the end, because most of the time the machine don't have any waiting time. Okay, no idle time. So at the end, it's finished at minute 30th, and the whole process finished at 49. So machine 1, it's already finished their job. So the machine 1 just stand by, not doing anything for 49 minus 30. So it's 19 minutes. So the 19 minutes is the idle time for machine 1. Okay, for machine 2, the first job is in machine 1. So machine 2 is waiting for the job 1 to be completed. So the machine not doing anything for 4 minutes. Okay. And then we will look at the in between. So we look at the out and in here. So 8, and then the next process is going to be 10. So the difference is 10 minus 8. And this one is 12 and 13. So there's a difference. So it's going to be 13 minus 12. And this one 19 and 21. So it's going to be 21 minus 19. And this one is 24 and 30. So they're going to be idle time, in which 30 minus 24. And don't forget, the machine 2 will finish at time 35. And then the overall process is going to finish at 49. So there's a idle time for machine 2, in which going to be 49 minus 35. So altogether, if we add up all the idle time for machine 2, it's going to be 29 minutes. Okay. And now let's do for machine 3. For machine 3, okay, when we look here, The first one, the machine 3 is idle because it's waiting for job 1, 4 minutes in machine 1, and then job 1 will be another 4 minutes in machine 2, so 8 minutes. Machine 3 didn't do anything. Okay, they're waiting for the job 1 to get into the machine. So 8 minutes they are doing nothing. So in between when we check, okay, 14 and 14, okay, there's no difference. 22 and 22, there's no difference. 29 and 29, no different. 40 and 40, there's no different. Okay, so for machine 3, the only idle time is at the beginning. So only 8 minutes. Okay, so when we look at this, we know that machine 2 is have the most idle time. So it's not good for the company or the manufacturer. So this machine have bottleneck, means that it will slow down to get into machine 2. So you need to improve machine 1 in order to reduce the idle time in machine 2. Maybe you have to speed up, you need to upgrade the machine 1, or maybe you need to add one more machine, okay, in machine 1. So all of this will help to reduce the idle time for machine 2. And machine 3, 8 minutes is okay. So usually the question will ask the total idle time. So you need to add up all the 3 machine. 19 plus 29 and plus 8. So the total idle time for all 3 machine is 56 minutes. Okay, we're done with the machine idle time. And now we're going to look at the job waiting time. In between these 5 jobs, is there any waiting time queuing before the job can get into the machine? Okay, so we look at job 1. So we look at the out and in between machine. So 4 and 4, okay, 8 and 8. So there's no waiting time for job 1. For job 4, we look at 10 and 10. Oh, oops, there's 12 and 14. So there's a job waiting time here. So 14 minus 12. For job 5, 13 and 13. And then, okay, here they have waiting time in which 19, and then they have to wait until 22. So going to be 22 minus 19. For job 3, 21, 21, and 24 and 29, there's a waiting time here. So 29 minus 24. And for job 2, this one, they don't have any waiting time, 30 and 30. But this one, they have waiting time in which 40 minus 35. Okay, so we need to add up all the difference between this one. And it's going to be 15 minutes. Okay, for the job waiting time. So we have conclude that we have the total processing time 49 minutes, and then we have the total machine idle time for 3 machine, it's 59 minutes, and the total job waiting time for all the 5 job it's 15 minutes. Okay, usually the question will ask you to draw the Gantt chart, so you can draw a Gantt chart for these 3 machines. So okay, that's all from me for the Johnson rule for 3 machine.